we are continuing our lesson on no solutions, one solution, or infinitely many solutions, which is standard. It's standard 8.EE, which stands for equations and expressions. .C.7. This is a long standard, and it's a lot of information in it, so it's very important that you guys prepare and study. The sheet that you were given on Tuesday, you can actually take that sheet out. And the sheet that I'm referring to is the one that has the infinitely many solutions, no solutions lesson on there. Also, which is the last notes that you actually took. So today's objective is I can develop strategies for writing an equation with no solutions, one solution, or infinitely many solutions. What I want you to do is turn to page 260, which is where I am now. I'm on page 260 in your iReady books. And I want you to look at the model it. That's this part right here where I put the star. And I would like you to try it on your own. You can use your notes with it. So what I would like you to do is pause the video, try to solve the equation, and then come back and let's talk about it. So go ahead and pause the video now. All right, now that you have actually done the problem, I want to see if you can solve and check your answer. Now, I'm hoping that you are following the directions I have on the video, because when I check your quiz on yesterday, I'm really not pleased at the results for most of you. So I don't know how many of y'all are actually taking the instructions and applying them throughout the video. So I'm hoping that you are. So it says that Mrs. Quinn writes this problem on the board. What number can you write on the line so that the equation has no solution? What number can you write on the line so that the equation has infinitely many solutions? Okay, so first off, we have to go back and identify what means no solution or infinitely many solutions. Because the first thing says, the first question says, what number can you write on the lines that have no solution? And what number can you write on the lines that have infinitely many solutions? Well, the first thing you need to think about is what is the similarities between a no solution and a one solution. So according to the notes that you took the other day, they both have the same variable coefficients for no solution and infinitely many. The difference is the constants. The constants are the integers. Integers are whole numbers and their opposites. So to write a number on a line, you could have written any number for no solution that is the opposite of 5. It could have been a number that's greater than 5 or a number that's less than 5. So for no solution, you could have put any number on this blank. So I'm going to say, I could put a 6, you could put a 7, you could put an 8, 9, 10, you could put 4, 3, 2, 1. Any number that does not equal 5 is no solution. All right. Then it says, what number can you put on a blank to have infinitely many solutions? Well, again, the variable coefficients, which is what I underlined in blue, have to be the same. But the constant term must also be the same for it to be infinitely many solutions. So I'll go ahead and rewrite this. It's 3x plus 5 equals 3x plus, on that blank, it had to be a 5. So this is infinitely many solutions. Infinitely many solutions. Okay, so infinitely many solutions. So hopefully you got that right. Okay, so it says you can solve the equation. So let's look at how the model it has broken it down so that you can actually solve the equation. You can actually put any number in here. Let's say I use 6. And I'm solving by subtracting 3x from both sides. That will cancel each other out. And it'll leave you 5 equal whatever number you choose. Okay? So it said think about what number gives you a false statement and what number gives you a true statement. So a false statement is if the constants don't match. And the constants I mean by the whole numbers. If the constants are different. What'll make it a true statement is if the constants are the same. So if the constants are different, you'll never have two whole numbers that are different that equal each other. So that's like when we solve this, and let's say we had this 6 there, 5 will never equal 6. Remember I told you put a not equal. In that same equation, if the constants were the same, and I replace that 6 with a 5, which I'll do. If I replace this with a 5, 5 equal 5 will make that equation true. Okay? So it's just solving it for infinitely many solutions, which means the constants must be the same. The variable terms must be the same. If the constants are different and the variable terms are the same, it's no solution. Okay? So what I want you to do is I want you to look at the analyzer at the bottom. It's basically reviewing the things we just talked about. It said you can analyze the structure of the equation. This is one of your vocabulary words, which are variable terms. Variable terms have coefficients. Coefficients are numbers in front of the variable. Both are the same on either side. The variable terms are the same or equal on each side of the equation. That's important information for you to know. It said think about how the constant terms on each side of the equation compare to the equation that have no solution. Remember they compare because the constant terms are different. It said think about the constant terms on each side of the equation. For the equation have infinitely many solutions. That means the constants are what? The same. The constants are the same. So remember, infinitely many solutions, constant terms are the same. For no solution, the constant terms are different. So please make sure you know that information because it's very important. All right? So right now what I want you to do is I want you to pause the video and I want you to work on numbers 1 through 4 by yourself. I'm going to ask that you give yourself about 10 minutes to work on numbers 1 through 4. Then come back and unpause the video. And then we'll work on pages. We'll check it and I want you to work on numbers 5, 6, and 7. Okay? And we'll walk through it and check it. So pause the video and then we'll come back and do numbers 1 through 4. Okay, now that you paused the video and you're back with us, it says look at the analyze it. What must be true about the constant terms on each side of the equation if the equation has no solution? Now we discussed all of this already, so it shouldn't be that difficult, but we'll walk through it. Okay, we know that it said what must be true about the constant terms on each side of the equation if the equation has no solution. Okay, so we're going to go ahead and write this in. The constant terms must be different for no solution. And the same for infinitely many solutions. So at the end of as you're working the problem, we already said that 5 equals 6 is no solution. And when we solve and have 6 equals 6, it's infinitely many solutions. And remember, I never like to write 5 equals 6 because I know 5 does not equal 6. That means no solution. All right? Let's look at number 2. Is there more than one number you could write on the line so the equation has no solution? Yes, we just talked about that. Yes. The constant term must be different. So you can write any number except what number? If you said 5, you are correct. All right, letter B. Is there more than one number you can use that you can write on the line so the equation has infinitely many solutions? If you answer no, you are correct. Answer is no. The constant terms must be the same. So 5 is the only answer. And number 3, it says, what constant term or x term could you write on the line so the equation has exactly one solution? Is there more than one possibility? How do you know? What constant term or x term could you replace? Okay, now first of all, let's go back to what the problem looked like. Okay, the problem was 3x plus 5 equals 3x plus blank. It said, what constant term or x term could you write on the line so the equation has exactly one solution? Now remember, in order for the equation to have exactly one solution, which I'm going to underline or highlight the word one solution. In order for it to have one solution, the constants the constants don't matter. Don't matter the number for the constants. But the variable terms must be different values. Okay, so if I put on this blank any number other than 0x, I can find one solution. Okay, I can solve for x. If I will continue to solve this will give me 3x plus 5 equal to 8x. Remember, we want our variable terms on one side and our constant on the other. So if we subtract 3x from each side, that'll leave me with 5 equals 5x. Therefore, x equals 1 when you divide both sides by the coefficient 5. Okay, so one great thing I love about math is that you can prove it. You can prove it. So any number, any variable term except 0x. And remember, we talk about variable term, we want the coefficient. We want the coefficient. Okay. All right, so think about the models and strategy we discussed, and I want you to do a reflection right here. This is for your own benefit, something you do not have to turn in, but I highly recommend that you do it. Right now, what I want you to do, I want you to pause the video. Make sure that you have all of your notes written down. Okay? Then unpause the video, and I want us to go through the apply it together. Then after we do the apply it, I want you to work on pages 263 and 264 on your own. Whatever you do not finish from 1 through 4 will become your homework. Okay? So we're going to, you can work on your own, or if you think you still need some help, we can work through it together. Therefore, you'll be able to be ready to work on your homework tonight. Okay, let's look at number 5. It says, High's teacher writes the equation 3x minus 4 equals 2 times the quantity x plus 3 plus x. High concludes that the equation has infinitely many solutions. Is High correct? So first of all, let's go ahead and solve this problem. Okay, if you want to pause and solve it on your own so that you can get more practice based upon that quiz that you took, I think more practice is needed. So the first thing, since we see a 2 on the outside of parentheses, we're going to go ahead and apply the distributive property here. So we're going to apply the distributive property here, which is 2 times x, and here, which is 2 times 3. All right, so we're going to work in order from left to right. So that's going to give us 3x minus 4 equals 2 times x, which is 2x, it's plus 2 times 3, which is 6, plus x. Now we want to combine our variable terms, and I'm going to highlight our like terms. Not erase, Marshan, highlight. So I'm going to highlight our like terms. So 2x, x, and 3x are all our like terms. Our constant terms that we're going to combine is 6 and minus 4. All right, so we're going to combine our like terms. 2x and x gives us 3x. And then bring down your plus 6 equals 3x minus 4. Now I see that I have the same constant terms the same variable terms and different constant terms. Okay, so let's go back to Han. He said that it has infinitely many solutions. In order for it to have infinitely many solutions, it must have the same variable term and constant terms on both sides. And it doesn't, because the constant terms are different, the variable terms are the same. Therefore, Han is incorrect. So no, Hai is incorrect. Why is it? Because the variable terms are the same, but the constants are different. All right? If you notice, I'm saying the same thing over and over and over and over again, which means that it's something that you have to study. Okay? Stop trying to take this class without preparing for the knowledge that I'm expecting you to know. There's no way around it. You must get it done. You must learn this information. It is crucial to your high school success. Okay? Which numbers could you substitute for C? So the equation 4 times the quantity, x, 4x plus C equals 2 times the quantity, 8x plus 1, has no solution. Select all that apply. So basically, what would C have to be in order for the problem to have no solution? If it has no solution, we need our constant terms to what? Be different. Constant terms must be different for no solution. So if we substitute and solve, okay, for our constant terms to be different, if C was 0, you should have 0, 1/4, 1, and 2. I'm going to go ahead and distribute this. This will be 4 times 4x plus 4 times C equals 2 times 8x plus 2 times 1. So that gives me 16x plus 4c equals 16x plus 2. So in order for this to be no solution, C cannot be 1/2, because 4 times 1/2, what's half of 4? Half of 4 is 2, which will give me this constant term over here, which will make it an infinite solution. And the question is, I want it to be no solution. So the only term that will make this equation false is everything except for C. Okay? Because the ultimate goal is to have same constants, same variable terms, if I am focusing on infinitely many solutions. If I want no solutions, I'm focusing on different different constants, and same coefficients. Let me say that again. No solution, I want same variable terms, different constant terms. Okay. Number 7, write a constant term or variable term on the line so that each equation has a number of solutions shown. If I want for letter A, no solution. If I want no solution, it can be any number except what? Except 1. So you could put any number on the line except number 1 and you're correct. If it's one solution, you could have any number as the coefficient. Coefficient is a number in front of the variable except 0. Coefficient didn't look right to me, so I'm going to rewrite it. Coefficients. I still wrote it the same way. That's 2 F's here. I don't know why I keep doing it. Letter C, infinitely many solutions. If it's infinitely many solutions, remember I have the same variable term, and I should also have the same constant term to be infinitely many solutions. For D, infinitely many solutions, again, I have the same variable terms, and I need the same constant. Now, mind you, this is a minus sign. In order for it to be infinite, I also must have a minus sign in front of this 4. Why? Because if I rewrite this, it'll be 2x plus 4 equals 2x. A negative in front of that negative make that a positive 4. So if you just put a regular 4 there, that's incorrect. It had to be a negative 4 for it to be infinitely many solutions. Okay? And of course, I always like to write that inside parentheses. Because that lets you know that, remember we talk about additive inverse. Additive inverse means you add the opposite. So 2x plus, keep the first number, it doesn't change. Make subtraction into addition and take the opposite behind it, additive inverse. Okay? All right, guys, I hope you enjoyed today's lesson. I know it's a lot of information. I really want you to study. I look forward to seeing you on Monday when I get back. In the meantime, what I want you to do is I want you to continue to work on the practice problems, numbers 1 through 4, all numbers, pages 263 and 264. All right? You all have a great evening.